Now come for question number 2. In this question, find the smallest whole number by which 512 must be multiplied in order to give a perfect square. So you can see from the statement that the smallest whole number by which 500 must be multiplied to get a perfect square, that this number is not a perfect square. So which number will be multiplied by this number to make it a perfect square? So the thing what we have to do, question number 2, we will make the factors of the number 512 first, as we have learned that in previous classes. These are the factors of 512. 2 ones are 2, 2 5s are 10, 2 6 are 12, 2 1s are 2, 2 2s are 4, and 2 8s are 16, and up to so on. So the square root of 512 will be, you can see, 1 2 3 4 5 6 7 8 9, 1 2 3 4, and this is a pair. Again this one is a pair, this one is also a pair, this one is also a pair, but this 2 is a single. So all the factors should have a pair to make it complete square. So this 2 is a single one factor, so it has no pair. So to make it a perfect square, it also should have a pair. It also should have a number 2 to make it pair, so that it can make it a complete square. So the statement would be, its answer will be that 512 must be multiplied by 2 to make it a perfect square. So this number should be multiplied by 2 to make it a perfect square, because all the digits are having a pair, but this 2 is a single one. So to make it a perfect square, it should be multiplied by 2. Now come for question number 3. Find a lowest number by this must be divided in order to yield a perfect square. There will be also the same situation here, it would be multiplied. So if there is an extra digit, so we will divide it by that digit to cancel that digit. So if we are going to cancel that digit, so we will write here that this number must be divided by this to make it a perfect square. Now come to question number 4. The statement of question number 4 is, the product of two positive numbers, any two numbers, and the product of these two numbers is this, and the larger one is 9 times the other. Find the numbers. So in question number 4, it is given that two numbers have the value, the product of two numbers, product is this. Let first number, let the number is x, and the situation is given that and the larger one is 9 times than other, and given that the larger number is 9 times more. Nine times more the number. So given that, according to the condition, according to the condition, the product of two numbers, these are the two numbers, first number is x and the second number is 9 times by the first number. So the product of these two numbers is 15876. This is the product of these two numbers. So we will multiply x by x, it will become x square, as a multiplied by a will make it a square. So x multiplied by x is become x square, and the 9 is 15876. To make it only x square, we will divide it by 9 on both sides. This 9 will be cancelled by this 9, and we will divide this. 9 ones are 9. By dividing this, we get the answer 1764. And here is x square, and we have to find the value of x. The number we have to find, that is x. So we will take a square root on both its sides because we need the number x. So here the given value is x. So here is also given the square root x. To find the square root of this number, we will do a procedure of factorization, that is 1764. So you can see that these are the factors of this number. So we will write them as 2 multiplied by 2 by 2 by 3 and 3, 7 and 7, and then we will follow the same procedure that we have done over here, like this, making the pairs. Square of 2, then the square of 3, then the square of 7, and instead of going to next page, so I'm going to solve it on the same page. So we will take common all the parts, and these parts will be cancelled by this. So 2 multiplied by 3 multiplied by 7, 42. The first number, that is x, that is 42, is the first number, and the second number was 9x. So we will multiply the first number by 42. That is, the one number is this and the other number is this. Now come for question number 5. In question number 5, we have to find the lowest perfect square number that is divisible by all these numbers. First of all, we have to find the number that divide all these numbers at the same time, and then we have to find the square root of that number that divides all these numbers. I'll give you a hint, and will help you to solve, and then you have to complete that question by yourself. In question number 5, we have the numbers 12, 16, 20 and 24. So first we have to find the number that divides all these numbers. So to find that 12, 16, 20 and 24, so we will find the number that is, all these are even, so we will start it from 2. Now 2 6 are 12, 8 are 16, 10s are 20 and 12s are 24, and then with the same procedure and this is all these, and this is the number that is divided by all these numbers. 240 is divided by 12, 16, 20 and 24. Now we have to find out the square root of 240. What is the square of 240? Now we will find the square root of this number, as the given condition is this and this. Find the lowest perfect square number, that is divisible by this, and so you can see that these two numbers are the pairs, these two numbers are also the pairs. This is a single one number, this is also a single one number. So in order to make this whole number a perfect square number, we will multiply it by 3 and 5 to make it a perfect square number. So we will write here a statement that is 240 is not a perfect square number. To make it a perfect square number, we need to multiply it by 3 5s are 15 by 15, 3 and 5. So now after multiplying it by 3 and 5, this is a pair. Again 2 multiplied by 2 is also another pair. 3 was a single and we multiplied it by this 3. This 5 is also a single number, so we'll multiply it by another 5. Now we will multiply all this multiply 240 by 15, means to say we will multiply all these by 5 and 3. So when we multiply 240 by 15, so we get the answer that is 3600. So 3600 is a number that is a perfect square. Now come for question number 6. It is very important and interesting question. That is, the sum of the squares of two positive whole numbers is this. Sum of squares. If there are two squares, for example x and y, two squares, and their sum is this number, and one is given 13, and we have to find the other number. Again, the sum of squares of two positive whole numbers. These two are, for example, these two are the positive whole numbers, and the sum of their square is 794, and one number is given 13. So first square is 13 square, and we have to find the other number. Now come for the solution of this question. What the condition is: sum of squares of two numbers is 794. If one number is 13, let x is a number and the other number is 13, so the one square is 13 square, and we have to find this number. So to find this number, this is extra over here and being added over here, so we will subtract it to the right side. So 794, what's the square of 13? 13 square means that we have to multiply it twice, so that 794 minus 169, answer was 625, and we took a square root on both sides because we have to find the value of only square. So what we did, we just make the factors of this one. So 5 5s are 25, and then 5s are 225, and then 5 6 25, the square root of that, and then we make the pair and then took the power common and then cancelled it. 5 5s are 25, the value of x is here, the value of x is 25. So the first square is 25 square and the second is 13 square. So you can check it also by keeping here the value 25 square and then opening the squares and then adding. So the answer will be 794. Now come for the last question of the exercise, that is question number 7. A gardener with 5,770 plants wants to arrange them so that the number of rows of plants equal to the numbers of plants in each row. Means to say, if he is planting 7 plants in one row, so there should be 7 plants on this side. So he want to make it a complete square, so he has the number of plants this. When he does so, he discovered that the number of plants falls short by 6, that he has a shortage of 6 plants. Find the number of rows that the gardener wants to make. So how many rows he wants to make? He wants to make a complete square. So there was a shortage of these plants. So we will add this number of plants into this. Gardener has the plants. How many plants? Shortage 6 plants only. So to make equal rows or square, he will add 6 plants more in this. So now he will take a square root of 5776 . In the same way, he will take the square root, and you have to take the square root, you will make the factors and then you will take the square root, and you will discover that how many plants will in each row and how many rows will be constructed at that time. So this part you have to solve your own.